Hello. We are about to discuss the conjugate beam method. What is conjugate beam? Conjugate beam, corresponding to a real beam, is a fictitious beam. Fictitious beam is the conjugate beam of the same length as a real beam. It is externally supported and internally connected such that if the conjugate beam is loaded with the MEI diagram of the real beam, the shear and the bending moment at any point on the conjugate beam are equal respectively to the slope and deflection of the corresponding point on the real beam. So remember that theta is the slope and it is equal to the shear or the area. So the delta or the y or deflection is equal to the moment. So these are the sign conventions. So if we have a positive MEI, M over EI, so it is equal to the upward loads with y direction, and if it is equal to the negative M over EI, we have the negative downward loads. So the very important here is this. You have to remember this. The transition or the translation from the real beam to the conjugate beam. So if it is fixed here and ruler here, it's still the same, there's no change. But if it is a cantilever beam, the fixed ends will turn into a free end, and if it's a free end, it turns to the fixed end moments. So etc. You have to remember this, you have to note this. So we have a example. So we are asked to find the slope and the deflection at the theta b using the conjugate beam method. So first we have to determine the reactions. We have the EY, the assumed direction, AY, AX, and the moment at A. Automatically, because there is no horizontal force, is 0. So the summation of vertical forces equals to 0, positive upward. So AY is equals to the 90 kilonewton upward. Summation of moment at A, consider positive clockwise. Could also consider counterclockwise as a positive, depending on you. So we have 90 kilonewton clockwise multiplied by 5 meters. So we have a 450 kilonewton meter clockwise. So the resisting moment therefore is equals to the moment of A is equals to 450 kilonewton meter counterclockwise. So this is counterclockwise, 450 kilonewton meter, and AY is 90 kilonewton above. So we were about to draw the shear and moment diagram. So we have from 0 upward to 90 kN. Then we have 90 here too. 90 minus 90 is equals to 0. This is our shear diagram. Then for the moment, for the MEI diagram, we have automatically negative 450 because it's counterclockwise over EI. Negative 450 plus 90 times 5 is equals to 0. So we were about to translate this real beam to conjugate beam. So as a rule, if it is in fixed ends, you change it to free end. If it is free end, you change it to fixed. Still the same point A and point B. So we were about to determine the slope. So slope is equals to the area in this. The slope at B is the area along this from here to here, the area. So for theta B and delta B. So delta B is equal to the area, summation of area from point A to B. So we have the area of, so theta B is equal to 1/2 of, it's negative 450 kilonewton meter over EI times the distance of 5 meters. So theta B is equals to negative 400, negative 1125. So 450 times 5 over 2 is 1125 kilonewton meter squared over EI. So we have a EI constants here. So let's just substitute. So we have a negative 1125 kilonewton meter squared multiplied by 1 kilonewton is equals to 1000 newton all over 200 gigapascal, which is 10 raised to 9 newton meter squared, multiplied by I, which is 800 times 10 raised to 6 mm raised to 4, convert it to meters, which is 1000 mm raised to 4 equals to 1 meters raised to 4. So we have here a theta B is equals to negative 1. So we have, so negative 1125 times 1000 over, all over na lang natin, 200 multiplied by 10 raised to 9 times 800 times 10 raised to 6 all over 1000 raised to 4. So we have negative 0.00703 rad. So theta B therefore it is equals to 0.00703 rad downward, because it's negative. That's our answer. So for delta, the moment, so delta B is equals to the summation of moment from point A to B. So we have here this one, the moment going to here. So we're about to find the centroid of the triangle. So as the sign convention, so it is a negative MEI diagram. So we have a downward load, which is the distance of 2/3, distance of 5 meters. This is 5 over 3. That is the distance of the centroid. So we're about to have a moment here. So the summation of moment at B is equals to, consider positive. So we have a counter clockwise. So therefore, this counterclockwise, we have a 450 kilonewton meter over EI multiplied by 5 meters by 2/3 by 5 meters. So we have, this is equals to the delta B. So delta B is equals to, so 450 times 5 squared times 2 over 6. So we have a, it's actually a negative because it's counterclockwise. We consider the positive is clockwise. So we have here at negative 3750 kilonewton raised to over EI. So I have to substitute the EI constants. This. So we have negative 3750 kilonewton multiplied by again 1000, 1 kilonewton equals to 1000 newton all over 200 times 10 raised to 9 newton meter squared multiplied by I 800 times 10 raised to 6 mm raised to 4, convert to 1000 mm delta B. Negative 3750 times 1000 all over 200 times 10 raised to 9 times 800, times 800 times 10 raised to 6 over 1000 raised to 4. So it is in meter, negative 0.02344 meter. So therefore, we have convert it to mm. 1 meter equals to 1000 mm. So we have delta B is equals to times 1000. We have a 23.44 mm downward because it's negative. So it's our answer. That's all. Thank you. Please subscribe. This is Lenny Villar.